Okay, so this video is going to cover how to make a scaled topo model from a 3D model in Rhino. So I have here my three-dimensional model of a topography. It's scaled at the moment 1:1, 1 foot equals 1 foot, so it's full scale. And I am going to, this is a mesh. I'm going to turn it into a NURBS, or I'm going to use it to make a NURBS surface, which is easier to edit in Rhino. And then I'm going to crop it down to a smaller dimension and scale it, and then turn it into a step file or a contour file for a template for a physical model. So I have here two outlines. One of them is the overall outline, and one of them is kind of a zoomed in outline. And I want to just start by taking the area of that outline and scaling it down. Before I do that, I'm going to make a new surface. So like I mentioned, this is a mesh, and I'm going to make a NURBS surface, which is Rhino's kind of native geometry, by using the command drape. And drape will just kind of like, drape a surface over existing geometry. So it should kind of like, almost like shrink wrap it. So when you use the command drape, you want to make sure you're in top view. And when you type in drape, it's going to ask you to select an area or a window. And notice that I'm clicking just inside the boundary, the outline of that surface, not beyond the boundary, because then it'll, drape over the edge. And I don't want that. I just want it to be inside the surface. So click there, and it automatically made a surface for me. I think, I could also, when I click drape, when you type in drape, you can also change some of the options like spacing and resolution, but it should be fine with the default settings. So there's my NURBS surface. I'll turn my other topography off, turn the image off. Okay, and so now I have this in a NURBS format, and what I'll do next is I'm going to copy all of this. So I just use the command copy, place it over there, and I'm also going to change into top view here again. I'll use my smaller outline to trim my NURBS surface. And you'll notice that even though the outline isn't touching the surface, when I'm in top view, it'll kind of like project it onto the surface. So it'll still work that way, like trimming works that way in Rhino. So there's my little surface, and that's about a 2 by 300 foot area. And what I want to do next is, well, before I do that, I could modify the topography now if I wanted to. So you'll notice that the kind of lines that show up on the surface, which are called isocurves, represent the number of control points that define that surface. So if I click this button over here, select a surface, it's also the command points on. You can type that in, or you can click this button. There's two commands. There's one called edit points. There's one called control points. If you just type points on, that's the control points. And so you'll also notice that when you trim a surface, it doesn't, it trims away the part, outside where you trim, but it doesn't actually remove that information. So all the points that define the surface around where I trimmed are still there. Now I can also, if I wanted to change the resolution of this, I could use the command rebuild. And so that will change the number of control points I have in each direction of the surface. You can see here the U and V represent those two directions, and the number in parentheses represents how many points I have in each of those directions. I also want to change the degree to 3, which will make it kind of freeform curve in each direction. So if I change it to, let's change it to like half what this is. So 3 by 30. What you'll notice is that I'll have fewer control points, and that the surface will actually get a little bit smoother or a little bit kind of more simplified. If I wanted to add some detail, I could also turn those numbers up, which would allow me to, let's do like almost double. That would allow me to have more control over the geometry of that surface. And now if I turn my control points on again, I can just grab them. This little green arrows, that's the gumball tool at the bottom. I can turn that on and off for objects. And I can use that to move points up and down, which modifies the geometry of the surface. And also, of course, move them in and out from each other, which can make the angle of the surface more steep. Okay. So you could modify your surface if you wanted to, if you had like a rock outcropping or something that didn't quite show up on the topography. Yeah, and you can obviously do a better job than that, knowing how it should look. But anyway, so let's go with that for now. Now, if I'm ready to turn this into my model, my physical model, the first thing that I want to do is scale it down into the size that it needs to be for the physical model. So before you scale it to the actual scale of the physical model, you want to select the surface. And I'm also going to select the outline, the boundary, type in scale, and click really anywhere. You can just click on one of the corners. And first you want to scale it 1/12 or 1/12, which will change it from basically from feet to inches. I'll press enter. So now it's like essentially 1 inch equals a foot. And now I would scale it again to set it to whatever my scale is. So if I were doing a model at 1/8 of an inch equals a foot, I would scale it again by 1/8. Instead, I'm going to scale this to 1/4 inch. And you can choose whatever scale makes sense for your model and the amount of area you want around your structure or whatever it is in your model. Okay, so that's 1/4 of an inch. Now this surface is actually literally 1/4 of an inch, so it should be the exact dimensions that we want our model to be. Now I could make another outline, and this time I should be able to actually enter what inches, like in inches, how large I want my model to be. So if I were to say do one that's 18, and because my file is in feet, which you can see down at the bottom, that's the units that my file is in, I have to write the quotes symbol. And that tells Rhino that I'm entering a units of inches rather than feet. And then I'll do like, I don't know, 24 inches, and I'll write quotes. Okay, so that's a new outline, and that's got the dimensions that I want. And, so whatever that size is, you'll choose that to make sense for your particular project. And then I would trim it again. So I'll use that rectangle. I'll go into top view and I'll type in trim. Again, I had my rectangle already selected, and I'll trim away the area of the surface that I don't want anymore. Okay, and now I'm ready to go ahead and make this into a contour file, or a set of contours that I can use as a template to make a physical model. And I'll do that the same way I would do it at a full scale. So I'll select the surface itself. I'll type in bounding box. Now, actually, I should point out, you can give it a base. You'll notice this is just the surface, right? So, in theory, like everything below the surface is ground, is solid. Everything above it is open air. So I could give it a base, and the reason that I would think that I would want to do that is when I contour it, I would also get like the outside outline of each one, not just the line that goes through the surface. So I'll show you how to do that. I'll use the command bounding box. And I already have my object selected, so I'll just press enter. And bounding box makes a box around my geometry at the extents of the geometry. Now, if I select that geometry, you'll notice that it's at the very bottom. Obviously, that's what it's meant to do. And I could just scale it a little bit so it's a little bit taller. And with the gumball tool turned on, I'll just grab the arrows allow me to move my objects around. The little squares allow me to scale things in certain dimensions, so I can stretch them out. I could grab that and just scale it down a little bit. And then if I select my topo surface and type in trim, and click on the part of the box that I want to trim away, I've made like a little base for myself with this model. And then I would select both of those sets of surfaces and type in join, just so that my curves end up being joined as well. And once I'm ready with that, I would want to make the contours for the physical model. So I'll select the object again and type in bounding box. And I'll just press enter to stick to the default. And then I'll type in contour. Now, again, I have my topo surface selected rather than my bounding box because that's the object I actually want to make contours of. And I'll click at the bottom on one corner of my box and I'll trace one of the vertical edges of my box. I'll click again at the top corner there. And then it will ask me what distance apart I want my contours to be. Now, this distance should be the exact distance of whatever thickness of material you want to use to make your stepped geometry. So let's imagine I wanted to use 1/2 inch foam core. I would type in 0.5, and I would also type in inches because remember we're in feet, so we need to tell Rhino that we want inches, and then press enter. And so that's what the kind of layers would look like. And this is obviously a very steep piece of terrain here. But once we have those layers, I can move them or copy them, doesn't matter. Okay. And I could then use this set of outlines to create the individual shapes that I would need to cut out to make a stacked model like this. Now I'm actually just going to do one really quick that's simpler because, again, I have a really steep topography here. So I'll do 1 inch, so you got to write inches, okay. All right, now there's a little trick to this. So if you wanted to do like a pure stacked topography like this, so I'll just give you an example. If I were to make each of these outlines into a kind of a geometry that has that thickness, that's kind of what we're making, right? We're making a bunch of individual cutouts out of a piece of material that has a certain thickness. And when we stack them up and glue them together, it creates a kind of stepped version of our surface. So that's kind of what it would look like if we made it out of 1 inch pieces. Now, in order to make those pieces, we would actually need to cut out, each of these shapes out of a piece of material. So in order to lay out these pieces individually so I could print them and use them as individual templates, in other words, I could lay out kind of each layer separately so that I can print them out separately and use them as templates and cut out the shapes one step at a time. Now, obviously they're all stacked on top of each other. There's a really easy, quick way to separate them. So I'm going to select all my outlines, all my contours. I'm going to go into front view, sorry. I'll type in zoom in the command line, and then I'll use the option selected. I still have my outline selected, so it should zoom into right where those contours are. So I'm looking at them straight on now from the side, which means they all just look like straight lines. And I'm going to use the command shear. And it's going to ask me what origin point I want. I'll choose one corner or the other at the very bottom. And then I'm going to drag my mouse way up here. I'm not going to snap to anything, but I am holding shift to snap to ortho, like 90 degrees. And I'll just click somewhere where I'm not snapped to anything. So there you can kind of see, let's actually, a little bit tricky, but what we want to kind of do is separate. So we're kind of like moving them all. Now, these are all two-dimensional outlines. So when I shear them, I just move them in one dimension. So because I drew that line perpendicular, it should just move them all separate from each other. And that will give me, if I go back to top view, every single individual one like separate. Let me show you how to do that in 3D in case it's kind of confusing. So now I'm in top view. I'm going to select, and I'm in, well, let's do it in perspective actually. So I'll select all my outlines. I'll type in zoom, and I'll hit that option selected to zoom in on those outlines. Now I'm going to type in shear, and I will click on the bottom corner of one of those outlines in the top corner. So I'm tracing like a vertical edge there. See if I can get it to. Not really sure why they won't show up. They must just be too far apart. Let's try it with a smaller spacing there. Oops. Oh, okay. So I think it doesn't work in this view. So you have to do it in front view. So, all right, scratch that. So do it in front view. So if you're in your front viewport, and you can set any viewport to front by going set view front. Type in shear, snap to two corners. And then you want to move them so each line is just barely clearing the previous, kind of like that. Okay. A little tricky, not to snap to anything. But. Okay, so then again, if you were in top view, and I'll type in top view, there's all our individual contours kind of laid out in sequence. I'm also gonna, so now what I would do is I would actually start to lay them out on sheets so I could easily cut them out. Now you could number them or label them if you wanted to. I could type in text and I could say 01. And obviously make that a lot smaller. But if you keep them kind of in order, and especially with this topography that I'm doing here, it's like each one just gets bigger. There's kind of not that complex. So I'm just gonna go ahead and lay them out. I could also copy this and then change it and then print those numbers on my sheets. But anyway, so I'm just gonna lay these out. What I want to do is put them in a layout that will fit on my printout. So in order to do that, I'm just going to type in rectangle on the command line, and then I'll type in 36 inches by 24 inches. I'm going to make a rectangle that's the size of my layout. Now, if you remember correctly, we actually made our model 18 by 24. You could also do a larger sheet. There's a sheet called Arc E, which is a 36 by 48. We could do that. Let's do 48 inches by 36 inches. Okay. And so then I would just have to make each sheet, have my pieces laid out. And hopefully you have fewer sheets than I do. And, once you start doing these ones that change in size, you can put other ones in there. Again, this is kind of simple because each one is smaller than the previous. So that would be easy to figure out what order they go in. If it's not easy, I would recommend labeling them. And we're almost there where we can fit 2 on the sheet. Yeah. And fit 3 on a sheet there. And these can probably go up here somewhere. Anyway, so you just kind of lay it out, try and make as few prints as possible. That's Hidea. And once you have each of your pieces laid out, those are the same, so I could just print that sheet twice, but I would go to new layout. Now, like I said, there's 24 by 36, there's also 36 by 48. The large format plotters we have can handle that size. And I would select my window, go to properties, click on the little detail. Sorry, I'm in my, oh yeah, so my, my detail window is on a layer that's white, which is why you can't see it there. So I would click on the detail window, which is like my little window into my Rhino print space, my model space. And I'll go, let's see, where am I? Go way into here, I think. Okay. And then I'll double click to exit and I'll select the detail window and I'll type 1 inches on the page equals, sorry, not 1 foot on the page equals 12 inches. 1 to 1. And so then I could make a series of layouts. Make more, or you can duplicate. Or I could right click where it says page 1, go to move or copy, move to end, and check where it says create a copy. Click OK. And then all I should have to do is double click inside the detail window, select my layout window, type in zoom, it's selected, and then scale it 1 to 1. 12 inches equals a foot. make a series of layouts that way. Once you're done, then you right click and you go to print. And again, we want to make sure our paper size is set correctly. When you're ready to print, you would actually change it to the printer that you're going to use. And then you would also go to view and output scale. If you want to do a multi-page PDF, you just click all layouts, and then it'll take me through each of my pages there. And I would change the scale again here to be 1:1. So it should be 12 inches equals 1 foot. So that's each of my pages kind of the same as my layout. And now when I click print and save it somewhere, should give me a document with those outlines. Now, the other thing I neglected to mention really quick is you probably want to give these lines a line weight, otherwise they'll print very, very thin. So yeah, before you print, you just want to, not the line type, sorry, change the print width to like, something that's just a little bit thicker than, it's kind of easier to see. So that's 1:1, so that's pretty good. And then, yeah, essentially what you do is you print that out and you can, temporarily lay the sheet by using tape or pins or any number of ways onto your material and just trace the outline of that material. You use your box cutter, your hot wire, whatever it is, trace the shape in order to cut out the material, and then you can remove the paper and stack them up. That's how you use Rhino to make a stacked topo model. All right, I will go ahead and end it there.